Welcome back to the series of text in Geometry Notes. This is part 3, and in part 3 we're going to look at rounded multi-level beveling, completely made from scratch with Geometry Notes. In part 1, which was a very old video 2 years ago, we looked at how to create text in Geometry Notes, have more control over the topology. Part 2, that's where we came up with a basic bevel of a 45-degree bevel. Now we're going to take it a step further where we round the bevel, and we're going to use a new feature in Geometry Notes called the repeat zone, which is really cool and very useful for what we're trying to do. So I hope you will enjoy, subscribe, and let's dive into Blender. And this is where we left off in part 2. We have split our Geometry Notes into 2 parts. The first part creates text, so we can specify our text over here, specify a size and a text box size as well. And that worked out well, so we created some text. And let's minify that and then look at the meshify curves, the second one, where we take the text curves that we get from there, which look like this, then we turn them into a mesh. That's what we did in the last part. Let's clean this up a little bit. I'm gonna remove my nodes here, or at least hide them by hitting this. And also, I have this thing you might have noticed called Align that used to be a tool in, it used to be an add-on in Blender that was just among the standard add-ons that was included in Blender. But I think they removed it, and it is not really maintained anymore. So I forked it on GitHub, and I made my own version that I will make available in the video description, or maybe in the article that I will do alongside of this video, and you can get it there. But what I pretty much use it for is just to align the nodes, which I added a shortcut for, Shift Command N in my case. So if we hit Shift Command N, this is what we get, and that looks really neat. So yeah, that's just something I wanted to mention, in case you think I have some kind of magic going on. But if your nodes are messy, just Shift Command N and it just cleans it up a little bit, which is useful. So, okay, let's tidy this up slightly before we go into the rounded bevels. So the last part, we spent a lot of time figuring this stuff out, this normal, this index, sampling the index, getting the normal of the curve. And then after filling the curve, we capture that normal and we have it now available at the mesh level. And since this is so common and this kind of belongs together, this is what we're doing here is pretty much filling the curve, but capturing the curve normal. So we can just make a group out of this with Control G, and let's take a look. We have 2 geometry outputs, which is a little bit weird. So let's plug both of the outputs. Let's use only the first one because they're the same. And then we can remove one. We can remove the second one here. And this geometry output is a mesh. So let's call it mesh to clarify that this is an actual mesh. And the curve normal, that's a good name, I think. And yeah, that looks good. So we can do, again, align the nodes, and that's very nice. And now we have a node group. Let's call it fill curve, but capture the normals or something. It's a bit long, but at least it says what we do. And now we have this single node that just fills up the curve. Then we extrude and join. I think that's fine. We could group this as well. And then we merge. So these 4 are kind of extruding the mesh. Oops, I just wanted to mute them for a bit. So yeah, we start with this flat, and then we solidify it pretty much. So yeah, that looks good. There's this really long connection going on here that is a bevel, but we also have a group input here which has a bevel. So let's instead plug this one in, which is exactly the same. And yeah, that's just a little bit tidier. and everything still works and looking good. So, all right. So this bevel pretty much happens here. We extrude up and then we set the position in. So if we disable this set position, we only move up. If we disable this extrude, we don't even extrude. So these two are doing the bevel pretty much. And what we want to do with a rounded bevel is we don't want to move it, extrude it once and move it in once. We want to do that multiple times. So let's match the drawing here. So we want to do it like you can see here. This is one step, this is another step, this is another step, and then this is the final step. So these are like 1, 2, 3, 4 steps of extrusion and moving it in. And so let's make that first. Let's make a multi-level beveling method. And yeah, there is this new node. It's not really a single node. It's like a new feature in geometry nodes. So let's make a little bit of room for this, and we can tidy it up later if we want. The new feature is called repeat zone, I believe. So we have another zone called simulation zone, which is useful. I haven't covered that yet, but we might do that in the future. But then we have utilities and we have a repeat zone, which is a really powerful concept because this allows us to do something to our geometry in this zone and repeat it a arbitrary number of iterations or repetitions. So this extrude and set position is the stuff that we want to repeat. So we have to do that in between those two nodes. So pretty much the way it works is you get some geometry in, and you can get other stuff in as well besides geometry. Then whatever goes in here comes out here directly, the first iteration, and you can do some stuff with it. Then it goes out here, and then the second iteration, you repeat that. So whatever you plug in here that's now modified will be available here the second time around. Then the second time around, you plug it in here. Third time around will be that at the end of the second time will be available now in the third one in the beginning. And then when we have done our last iteration, we go out here. So it's like repeating whatever happens here a number of iterations. So what we have to do is plug in our geometry before any beveling happens, and the final result will be our group output. Currently nothing is happening, so we don't see any bevel here. But if we move these two nodes in this area, and if you connect anything, this orange area will expand to the nodes to match, to make it clear that this is the stuff that's being repeated. And now you can already see that our bevel is back and it's just working as before, and we can change the size and everything just still works as before. So there's almost no difference, and there's actually literally no difference because we only do one iteration. And if you have a repeat zone with only one iteration, it's pretty much like you're just moving through this thing once, and these two nodes don't really do anything. They don't affect the geometry. So it's pretty much the same thing right now. But what we can do is we can do more than one iterations, and then we get something that already looks like a little bit of a rounded bevel, which is pretty cool. It's not very nice. It's kind of random, but it looks pretty cool. And this is the power of the repeat zone. We can just repeat stuff. And the reason why this looks a bit weird is I don't even know exactly why it has this shape, but the reason for that is that we're extruding a certain selection and then we're repeating that with the same selection. But what we should be doing is update our selection. So instead of moving this top directly into the selection, we can move it into the repeat node. And now we have a top here. We can move it in here. It doesn't really, it actually changes things, but we're not updating the top. So the first iteration, we're getting this top selection And then the second iteration, we don't do anything. We have everything deselected. So we're only doing one little iteration, and then we are not selecting anything. We're not extruding anything anymore. So that's why this happens. But now after extruding, we have a new top selection, and that's what we can plug in over here. And now we're getting a straight 45 or a 45 degree bevel, but with multiple segments. And as we increase the iterations, we get more of this bevel, which is already pretty cool. And this is a really powerful technique to do stuff like this using this repeat zone. One thing that doesn't make sense right now is that we specify a certain amount of bevel, and the number of iterations kind of increases how much we bevel. So let's fix that first before we go into rounded bevels. One way to do that is I want to expose this iterations to our modifier panel. And so let's do that. So let's grab an input, a group input node, move it over here. We might use the same one, but let's just do it like this. And then we can simply expose this iterations value over here. Now we get an iterations. Let's rename that to the bevel steps. So now we can do a multi-step bevel based on this setting over here. Let's look at the other settings just for a second. We have a default. Let's set the default to, actually, let's set the default to 0, no bevel. And the min should be 0. The max, let's cap that at 64 or something to prevent Blender from blowing up. And that looks good to me. Let's, okay, so now we can control the amount of steps over there. And that's nice, but the reason I did that was I just wanted to have this value. So now, instead of beveling this amount, we want to bevel the bevel amount divided by the number of steps, so that we don't increase the amount of total beveling by changing the steps. So a very easy way to do that is with a divide node. And we take the bevel, we divide it by the bevel steps, and that's going to be our new bevel amount. And we can collapse this node. I tend to collapse nodes that I know are clear what they do. So we take a value and we divide another value. I don't need to see the rest here. So I can just make it small. And yeah, we can take that instead of this bevel. And we can plug that in here. Oops. Plug that in here and plug that in over there. And now we can remove this group input node. And now we have a lot less bevel, so we can increase that a little bit. And now we can increase our steps an arbitrary amount, and the bevel doesn't really change, but we just increase the amount of steps. And that might already be useful. Still keeping it at this 45 degree angle might already be a nice feature to have. And the only thing where it breaks is when you set the steps to 0, our total depth is not 0.1 anymore. At step 1, we get to exactly this level of 0.1, our depth. But when we set that to 0, we lose that. So let's fix this, and it's pretty easy to fix. So where we set the initial level of extrusion is all the way back here, and we calculate this depth minus the bevel. So we can also actually minify this node because it's clear what it does. So we take the depth of 0.1 and we subtract the amount of bevel. But if we don't bevel by setting the steps to 0, we shouldn't subtract anything. So only when this bevel steps is greater than 0, we should subtract something. So the way to do that is take this bevel steps and check and compare it if it is greater than 0. And if it is greater than 0, then we get here a true value. This pink means it's Boolean, which you can also use for selections. It's either yes or no, true or false. But if you convert this to a number, true is 1 and false is 0, which is useful because now we can take this and multiply it with our bevel amount. And if we get false here, so meaning if we have our steps set to 0, we multiply by 0, and then we subtract that. So then we subtract 0, so we get the original depth. And anytime it's above 0, so 1 or greater, then we subtract the actual amount of bevel. So if we do that, it will fix our issue. Bevel steps set at 0, we just get the original extruded mesh at exactly 0.1 depth. And then when we move to a level of 1, our total height does not change. And then we can increase the steps from there. So that fixes this. We can collapse this, but then I'm not sure what it's greater than. So if you want to do that, you could rename this with F2 to say greater than 0. Something like that, if that makes it clear for you. And then we multiply these two and we subtract. So that is pretty clear what happens there. And that fixes our initial issue. So let's now move back to the repeat node. And yeah, let's take a look at this. So instead of these straight steps, we want to make it round. So how do we do that? Well, we can consider this like a point that we rotate around, right? And then we have this length here. We have R, and these two are both R. And this happens to be the same as bevel. So R is equal to the amount of bevel we're doing, because this is the level we specify. And we can specify anything we want. We can consider bevel, the amount of bevel, something different than this. But in this case, we happen to have this set to how much bevel we do. And in this case, it's exactly the same as R. So that's useful. And then the other thing we want to do is figure out the angle of these segments, alpha. So this is the angle where we are at. And if we have the angle and the radius, we can use the sine and cosine to calculate how far in the x direction and how far in the y direction one of those steps is. And that's what we should calculate in this repeat area. And then we keep calculating that for the new angle and for the new angle and so on. And that's going to be the main part of this tutorial, showing you how to do that. And from there, if you get that concept, you can do anything you want. You can even apply this to something other than a bevel. You could say, if you have this straight edge, you could add a subdivide level here and make something like this, or something round, where your profile just is something completely custom to whatever you want. But yeah, let's focus on this first. Okay, something, while we're repeating ourselves in this repeat area, something that would be useful to have is a index, or know which repetition we're in, because then we know what angle this is, or we can calculate what angle this is supposed to be. All right, so let's add something else here. And the way we added this top is just plugging in something new, and it will just add it for you. But you can also do it manually by hitting N and going to the node. And then in the properties, you can see these repeat items, and you can just add another one. And what I want to add is, this is the total number of iterations, but I want to know the current iteration we're on. And we can do that by adding an integer, calling it maybe just iteration. And that looks good. By default, it's 0, which is fine. Maybe I want to start at 1. Yeah, I think that makes a little bit more sense. And then I want to move it to the top because that's kind of part of this main loop. So that makes most sense to me. And now we have our iteration. How do we make sure that this is actually updating? Because we could plug it in right now, and now it will be 1. We go here, it's 1. We go back, still 1, because that's what we plugged in here. So that's not the right way. Instead, we just want to increment this by adding 1. And it's very simple. Just add 1. And we can collapse this, and I kind of know that this is an increment, so I'm going to rename this to increment. So I know what's happening. And another thing you can do, this input is kind of not useful, so we can hide that with Control H. And now it becomes very simple. Actually, I have to undo that by hitting Control H again, because it would also hide this, because it's unused. Let's use it by plugging it in here. And it doesn't really matter where you do this, but now we start with 1, then we increment it. So here it's 2. So the second time we loop, we start with 2, and it becomes 3, and so on. So now we have our loop, our iteration here. And hit Control H to hide that, so that cleans it up a little bit more. All right, so now we know that we are in number 1, number 2, number 3, number 4. What I would like to have is how far we are. So how, like, because if we increase this, then this last one suddenly becomes 6 or 4 or whatever we set here. So that's not too useful. So what I would like to do is divide this number by the total amount of bevel steps. And when we do that, we get a value that's more like between 0 and 1, which makes a little bit more sense. And in this case, we start with 1. So if we are with 4 steps, it doesn't really start at 0. It starts at 0.25 because that's 1 divided by 4. But that would be really useful. So I want to do that. I want to divide this by the total number of bevel steps. So let's do that. And now we have some kind of factor. So we can rename that to maybe the progress or something. And the progress is just, maybe also add that to make it clear. It's going from 0 to 1-ish. And with this progress, we can calculate the angle. So here it's 0, here it's 1. What is the angle? The angle goes from 0 to half pi, because a full circle is 2 pi. A quarter of a circle is half pi. And so we can easily multiply this to get the angle. And something cool you can do is you can just type in pi over here. And that gives you pi. We don't want to multiply by pi, we want to multiply by half pi. So we could add another multiply by half, but easier is just to say pi divided by 2. That's half pi, and that gives you just some value. And you can just hide this and say, this is our angle. And that's all we need to know. So now we have the angle. That's already very useful, because we can use this to take the cosine, and we need to take the cosine and the sine. Why do I start with the cosine? Well, I always imagine that when you're rotating and you want to, in this case, let's start with x. We want to calculate the amount of x that we have to move to the right. I know that this is going to be cosine because the cosine wave starts at the top when it's 0, and then it goes something like this. So I know that this is barely moving. So I know we're sitting here. And then when we are a little bit further, we're starting to speed up. And that's what we do with x. So I know that this only moves a little bit in the beginning. And that's because we are at the top right there. So this is the cosine. And the sine looks like this, where the sine is almost like x is equal to, or y is equal to x. So it's almost like a slope of 1 straight line. So that goes something like this. So for the y, we're already moving quite fast up. The y value is going quickly to above to the top right here. It's moving up very quickly. So I know that that is the sine. So we take our angle, we take the cosine to get the x value, but we also have to multiply by our radius, which is our bevel. So let's take the bevel, and that's going to be our total bevel. I was going to say, do we have to divide by the number of steps? But no, our radius doesn't change if we increase the number of steps, because that's what we handle with this angle. And here we are kind of dividing by this bevel steps. So we don't need this anymore. We just need the bevel, which is the radius, and we need to multiply the cosine with that radius. So let's add a multiply to find our, and we can just, this is clear that this is taking the cosine, and now we can multiply by the bevel, which is kind of multiplying by the radius, and we can rename this to the x position or something, to just make it very clear what we are working with. And let's add a little bit more space. Okay, so we could plug this into the x position, which is supposed to go here, because remember, we're first extruding, which is going up. That's the y direction in this case. In reality, in the Blender world space, it is actually the z value, but since this bevel stuff is happening in 2D, I consider this y and this x, but you can name it anything you want. It doesn't really matter. We're first moving up with this extrude, then we're setting the position to move it over horizontally in the x direction. So this is where we have to plug in how much in the x direction we want to move. So let's try that and see what happens. And this doesn't really work. I already knew it was not correct, because what we're pretty much doing is we're going step one, we're calculating how much in the x direction is this, and then we're taking that step. That is okay. But then the second time we do this, we calculate all the way from here to here for the second one, and we're adding that on top of where we already were. So instead of doing that, we have to subtract the previous value of x. So in order to do that, we can plug in some new values over here to remember where we were before, and then we can remember that in the next iteration, and we can subtract the previous x position. So let's add a subtract. And we could rename this to relative x in a bit to show, because that, like, we are actually calculating the real x position here. There's nothing wrong with that, but we shouldn't use that to move to the right, because that's too much. So instead we have to take the relative amount that we have to move compared to the last time. So actually let's plug this x position in here, and now we get this value. Let's call that previous x position. And now that's also available over here, and we can set an initial value. And then after the first iteration, it will be whatever we plugged in before. And now we can take that and subtract it from our x position. And now this will be our relative x position. And now we can plug in that. And now we're getting something that looks a little bit round. But let's think about what we're doing here. We are taking the cosine, and the reason why is what I just explained. Like, we're starting at this top where we're barely moving, but what we get is a full, if the radius is 1, we get a value of 1 at 0, while we actually don't want to move a lot. So we're already starting at this, and then we want to subtract from it. So instead of trying to explain it, I'm just going to show you, we should start not at 0, but at 1 if the radius is 1, or we should start at the value of whatever the radius is. And that happens to be the bevel. So we have to plug in the bevel, and now we're getting something that looks a little bit better and rounded. But we're moving in the wrong direction, because I'm actually not sure if if this is a positive value, we're moving in. So what we're doing here is we're taking a positive value and we're subtracting, we're taking the x position and we're subtracting the biggest value. So we're getting a negative value over here. So in order to fix that, we can multiply by -1. That would add another node, or we can just swap these two. And now we're starting with the biggest value, and then we're slowly subtracting x from this to move in that direction. And if we plug that in, now we're getting something that looks a little bit rounded. And this is cool, but it's not a real circle, because we're moving the same amount in y every time. And that's because we have this offset scale in our extrude still not calculated. But this is pretty much how you calculate this for the x. For the y, it's pretty much the same thing. Instead of cosine, we use sine. And so let's just quickly do that. So I'm gonna duplicate this, set this to sine, plug in the angle, get the y position by, and let's rename that before we get very confused here. We get the y position by taking the sine of the angle and multiplying it by our bevel. And I can actually hold control, I believe, and then right click, drag through this. Okay, that removes it. Shift, right click, drag through this to add a little point that we can use to plug in there. And we can kind of split like this. And this is our bevel value, or the same as the radius. Now we get our y position. We can collapse this again. And we have to save our y position at the very end, same way we did with the x. So let's look at this node and rename this to the previous y position. And now we remember the previous y position. We can access it over here. And the y position does start at 0. So that is fine. We don't need to plug in anything here. The y position is supposed to start at 0. So let's... All right, so we can read this. That's fine. Now, we want to take the difference between our calculated y position and then the previous one. The way to do that is to subtract. So this subtract, let's duplicate that. And if you are moving around your node and you don't want to drop it and let it connect automatically, like you see here, these noodles under the node are kind of lighting up. If you don't want that, you can hold Option or Alt to not do that and just drop it without doing that. Might be useful. So we take this y position and we're subtracting the previous y position. So in the beginning, we're subtracting 0 so that nothing happens. And then we're taking the y position, which increases over time. The previous y position is always smaller, and we want to end up with something positive. So here, we don't want to swap them. We don't just want to use it like this. And then we plug that into our offset scale. And now we have a perfectly rounded bevel going on. And you can see the bevel is too much, so this looks like crap, but we can now increase the steps to an arbitrary amount. We get a perfectly rounded bevel calculated with real nodes, sine, cosine, and we do some real math to calculate how this is supposed to go, meaning that you could tweak this to be whatever you want. And this is working really well, and we can reduce the amount of bevel to reduce that issue there. But I just wanted to match it up with the drawing. But yeah, that's how you do it. So let's tidy this up. This subtract will be the relative x change or something. X relative, maybe. And y relative, because we're subtracting the previous y from it. And then we can collapse those as well and make them a bit smaller. And that's it. It's relatively simple. I mean, it's only a few nodes, and you just need to draw some stuff to understand what to calculate, whether it be the cosine or the sine. And if you don't know at all and you can't figure it out, just try. Just try it. And sometimes you see it moving the wrong direction. If that happens, you just have to flip the axis around. So instead of a positive number, you want to get a negative number, or vice versa. And that means you can multiply by -1, or you can just swap around the subtract plugs over there. And that will also flip the sign. And yeah, that's pretty much it. And from here, I want to add one more trick that is really nice to fix some issues. So we have this beautiful bevel, but let's look at some, yeah, we still have some issues over here because the bevel is just too much. So let's see if we can do something about that. So what I thought about was, when you're in these corners, you're moving and you're collapsing. Like this stuff is collapsing into itself because we just go too far. So how about we just take every step, we just look at these vertices, and when they hit a certain threshold of being too close together, we want to just merge them. How about that? That would be pretty cool. So let's do that, because there's actually a node called merge by distance. And I don't know why it's at the top here. It already knew that I wanted to use this, but merge by distance. So this just takes a distance, and if two vertices get closer than this distance together, then they will be merged. And the normal values will be kind of averaged. So that is pretty cool. So if we have some points going like this, and their normals are pointing like this, then let's say we merge these two to one, it just takes the average normal, so that points kind of in the direction we want. So let's try this. So let's plug this in between and see what happens. And this already fixes, it's not beautiful, it's not pretty, but it fixes the issue at least. And yeah, that's pretty cool. So you can see here, it merges the next step. Instead of going, moving these 2 points up like that, and let's draw on our surface. Instead of moving up like this, it says, okay, now you two are too close together, let's merge into one, and that becomes one, and then these two become one, and it just merges together. And this is not beautiful modeling if you were modeling this by hand, but remember, this is just done by nodes, and it's all procedural. And we have done 0 hand modeling here. So with that in mind, I think this is pretty cool. And one other thing I want to do, in order to prevent merging anything that's going on here, maybe, you can merge only a selection. And let's only look at the top. And this also speeds up the merge node quite a lot, because we're doing this merge a lot of times, right? We're merging this 24 times. So instead of merging everything that is the geometry, we just want to look at the top layer, because that is the most relevant, and that still merges our vertices together here. And in order to do this a little bit better, we could try increasing this distance a little bit, and this is just something you want to tweak and play with. But yeah, this already looks quite good. I mean, it doesn't look pretty, but it fixes our issue of these flipped normals and these faces going crazy all over the place. So that is a pretty cool trick. Let's lower the amount of bevel steps to something like 8. And also lower the amount of bevel. I think this is a little bit much, maybe 0.2. And then we can try to increase this. No, it's very sensitive. Let's try 0.002. And yeah, this gives a decent result. In case you need to do more bevel than possible, you could just try this solution to kind of fix a bunch of issues. And you can always go back to the other nodes and hit the switch to try the other flavor of topology that we came up with in the last part. And that might also solve some issues for you. But yeah, this is rounded beveling, all done. And again, if you know this, you can do anything. You can do some kind of crazy profiles, and yeah, you can go crazy. So that's all. That's all I wanted to share. The most important thing is just this. Where are we? The most important thing is just this repeat area that is new in Geometry Nodes. It's very powerful. It can be confusing to use, but I hope this was a cool use case to use it for. And yeah, I will stop the video here. I will save the blend file, make it available for you to download on our website, blendergrid.com, where I will do a little article about this stuff where I also embed the videos. And so you can download the final node setup, but I recommend you to just play around with the nodes yourself, try to come up with this yourself, follow along, because that will give you a really good understanding of how to build things in Geometry Nodes. And it's just very powerful stuff. And yeah, I'm planning to do a lot more tutorials on this. So stay tuned for that. Have a great day, and I will see you in the next video.